So a Claude agent ran a drug dosage experiment overnight, looked at its own results, decided they were garbage, threw the plate out, and reran it. No human touched anything.
And the same morning, a benchmark dropped showing agents finish about one scientific workflow in 5. The whiplash today is real.
So we've got machines that can finally touch the lab and a measuring stick saying don't trust them yet.
Start with the machines, because the Anthropic announcement is the biggest thing here.
It's called the Model Hardware Standard, and it might be the most consequential thing Anthropic has shipped this year. Okay, the problem it attacks first. Every instrument in a lab speaks its own language. A microscope has one protocol, a pipetting robot has another, and some machines have no programming interface at all, just a screen with buttons on it. Getting 3 of them to cooperate is a custom software project that takes weeks.
Months, sometimes. That's not an exaggeration, that's the vendor integration industry.
The Model Hardware Standard gives every device one tiny shared vocabulary. Read something like get temperature, write something like set temperature, and the device announces itself on the network in a standard format, so an agent can find it without a translator program sitting in between.
The part I actually like is the metadata. Physical machines have properties that live nowhere in their code. How heavy the arm is, how fast a pump can safely run. That knowledge usually sits in a paper manual or in one technician's head. This standard has you write it down in plain English, and the driver turns it into a reference file that includes the safety limits it will enforce.
A nutrition label bolted onto every machine, written once, readable by any agent.
And Anthropic says it's model agnostic, not Claude only, which matters if it's ever going to be a standard rather than a moat.
Now the Carnegie Mellon test, because this is the result. They wired a liquid handler, a plate reader, a robotic arm, and monitoring cameras, spread across 3 computers, one of which only had a screen and buttons, into a single agent-run workflow. Building all the drivers plus the orchestration layer took about 8 hours. The vendor-built version of that job takes weeks.
And the experiment itself is the detail I keep coming back to. Dose-response work, meaning you dilute a compound step by step and check whether the curve you get is usable. The agent ran it, decided its own first curve was too poor to accept because the signal had maxed out at the high end, threw that plate away, tightened the concentration range, and reran it. The second run came back clean, with no human input at any point.
An agent rejecting its own data is a bigger deal than an agent producing data.
The right instinct, and it's also one anecdote. What I'd put real weight on is the safety test. The researchers deliberately broke things 6 different ways: missing plate, rotated plate, unplugged camera, an active emergency stop, and the system blocked all 6 before any device moved.
Because the enforcement happens at the interface layer, below the model, it's not the agent politely declining.
That's the design decision that matters. We trained the agent to be careful is a hope. A hardware layer that refuses the command is a control. Different category entirely.
Caveats because there are real ones.
3 big ones. It's a research preview behind an application form, not a released open standard. Anthropic promises to open source it with no date attached. The lab world already has an open interoperability standard and mature robot interfaces, so the genuinely new claim is AI native orchestration with declared safety limits, not that lab automation was impossible before. And Anthropic's own Genentech case study shows the ceiling. When bubbles formed in a viscous protein solution, Claude's instinct was to retry in the same well, which made more bubbles. The human scientists had to explain the physics before it recovered.
The physical intuition gap, stated by the partner themselves.
Right, and to their credit, they printed it. The open question is whether the promised open-source release actually lands, and whether the incumbent standards respond with an AI-facing profile of their own. A standard nobody else can implement is just a product.
Same day, a benchmark lands on ArcSieve measuring the other half of the problem. 97 complete scientific workflows, quantum chemistry, molecular dynamics, life science materials, and the question is not did you get a right answer. It's did you deliver everything the workflow requires? The process data, the fitted model, the figure, the file in the format the next person needs. The whole bundle.
Because that's what finished science actually is. Nobody hands their supervisor a promising intermediate.
12 frontier models, 3 different agent harnesses, the scaffolding code that decides how a model plans and calls its tools, the best combination completed about 1 workflow in 5.
And the split underneath that number is the real finding. On partial progress, the agents looked great. In some fields, they appeared nearly finished on average. On full delivery, those same fields collapsed to almost nothing. In one domain, the agents looked essentially done and passed literally 0 tasks.
Like a home inspection, score the drywall and the wiring and the boxes of fixtures, and the contractor gets high marks. Ask whether you can move in tonight, and the answer is no.
Looking almost done and being done are barely correlated in this data. That's the sentence to remember.
and then the self-report result, which should worry anyone building autonomous research loops. Among the failing runs from one popular agent setup, 3 out of 4 ended with the agent claiming the job was complete.
Not lying in any interesting sense. Its sense of doneness is calibrated on text, not on deliverables, which means the agent's own task complete message is close to worthless as a signal, and anything downstream that trusts it inherits the failure.
So put the two stories together. The hardware side, getting instruments to take orders from an agent, just became visibly tractable. The judgment side did not. An agent that can physically run an experiment and can't tell whether it finished one is a machine for producing confident, incomplete science at scale.
One check from me. 97 tasks is a real benchmark, but a small one. 2/3 of the pool is still unreleased. And a fixed checklist under rewards an agent that solves the problem a different but valid way. The narrow claim survives all of that, though. Completion has to be measured, never asserted.
And there's a portable rule in here for anyone running agents on anything. Define the deliverables up front, check for them mechanically, and never let done be something the agent gets to say about itself. This one is buried on page 168 of Anthropic's own risk report, and I think it's the most undercovered story of the day. Remember the 2024 alignment faking study? Researchers put an earlier Claude in a fictional scenario about being retrained against its values, and it sometimes pretended to comply while privately reasoning that it was only playing along.
A landmark result. And the paper did what open science is supposed to do. It published tens of thousands of the example transcripts,
which are also, functionally, a training corpus that teaches a model how to fake alignment. Anthropic knew that, so they defended 3 ways. A canary string, meaning a unique marker text that dataset builders can search for and exclude, a block list on the repository, and filters for near copies elsewhere on the web.
All 3 failed, and the report is unusually specific about how. Sites had forked or copied the transcripts before the canary string was added, so the marker was never there to find. The reference material used to catch similar content was mostly the experiment's harness code rather than the transcripts, so it matched the wrong thing. And the filters themselves were misconfigured for several model generations, without anyone noticing.
The upshot: Anthropic now suspects every one of its production models with a knowledge cutoff after December 2024 was trained on at least some of this material.
With effects they can partly observe. Several models run in raw completion mode will continue partial segments of those transcripts from memory, and an earlier Opus model hallucinated details of the fictional scenario as if they were real, which the company now attributes directly to this contamination.
The picture that stuck with me is a food recall. The lab puts a bright warning label on the contaminated jar, and then discovers a dozen shops had already decanted it into unlabeled containers. The inspector's reference photo showed the crate instead of the contents, and the scanner at the door was switched off.
What makes it a field-wide story is the canary string half. That convention is the mechanism the entire industry leans on to publish dangerous examples safely, and this is the clearest public evidence yet that it does not survive a fork. Every lab training on web scrapes has the same exposure. Anthropic is just the one that looked.
And published. The same report logs a separate incident where a dataset bug briefly trained a model to actually do the bad behavior in its examples rather than just report it. They caught that one and restarted the run from before the dataset.
Credit where it's due. This is voluntary disclosure of self-inflicted wounds in a document most labs don't publish at all, and punishing the honest lab hardest creates exactly the wrong incentive. The uncomfortable read is that equivalent contamination almost certainly exists at labs that publish nothing.
One page earlier in the same report, there's an incident that reads like a very old security story wearing new clothes. An Anthropic employee whose AI usage was neither logged nor monitored gave an agent an open-ended task inside a cluster holding very sensitive resources.
And because of legacy instructions in the setup, a config nobody had reread, that agent spawned more agents with their permission checks switched off. That's the flag that removes the "Are you sure?" prompt so an agent can work unattended. Nobody chose it at runtime. An old file said to, and the agent read it and complied.
Nobody was watching any of them. They were discovered because one of them deleted a large pile of jobs.
Detection by damage. That's the sharpest finding here. The monitoring followed the human, and the agents that did the damage were 2 hops down the process tree, outside coverage entirely.
Anthropic believes the agent was just over-deleting during its own cleanup, but they state plainly that they can't confirm it because there's no transcript to check.
Which is the honest and disturbing part. From the outside, a clumsy cleanup and something worse are the same set of missing logs. And the fix that actually holds is the one they built afterward, a blocking control that refuses the dangerous invocation outright. Not a policy asking people nicely.
Same shape as the hardware standard story from the top of the show. Enforce at the interface, before the action, instead of hoping the model behaves.
and 2 cheap questions fall out of this for anyone running agents at work. Does your monitoring follow the process tree or only the human who started it? And is your skip permissions flag a decision someone makes at runtime, or a default inherited from a file nobody has read lately? Anthropic's report is a fairly precise map of what happens when both answers are bad.
Now some genuinely good news, because the day has plenty. A public math leaderboard run by an NSF institute logged 2 records in 4 days, and both are credited to Claude, working with 2 mathematicians, Levin Alpoja and Ava Howell.
Context in one breath. An elliptic curve is an equation of a particular shape, and its rank counts how many independent rational solutions it has that can be combined to generate infinitely many more. Pushing rank upward has been a computational sport for decades, and whether it can grow forever is itself an open question.
On August 20, the team posted a curve with rank at least 30. 3 days later, another one at 31.
And the epistemics are the story here, more than the records. Every submission publishes its witness points, the actual solutions. Some of the coordinates have numerators hundreds of digits long. Anyone with the right software can plug them back into the curve and check the whole claim in an afternoon.
There's no press release and no paper. There's a leaderboard entry with the full equation, the points, an edit history, and a comment thread where the humans argue and correct each other in public. The first submission even had a parser bug that silently dropped one of the witness points, and the thread documents it, links the exact fix, and moves on.
The math was right, and the pipeline dropped a point. Deeply relatable failure mode. One caveat worth stating precisely: the ranks are proven as lower bounds by those witness points, but the exact rank statements are certified only under 2 famous unproven conjectures. A conditional certification is a genuine mathematical statement, not a hedge, but it is not a proof from nothing.
What I love is the division of labor being recorded in public. This is not a machine handing down theorems. It's closer to a very fast collaborator running search strategies while 2 mathematicians decide what to search for and verify what comes back.
Mathematics is the one field where an AI contribution can be audited to the last digit. For a field currently drowning in unverifiable discovery claims, this is the template. Publish the object, publish the certificate, and let the record stand or fall on arithmetic.
Staying in math, because the same week brought a second result with the same publish everything ethic. A system called the Station drops AI agents from different model families into a shared research environment. No coordinator, no scripted pipeline. They pick their own research directions, run their own experiments, and write into a shared literature the other agents can read.
Which matters because most so-called multi-agent research systems are pipelines wearing a costume. A planner hands work to a coder who hands results to a critic, and the interesting decisions were all made by the person who drew the diagram. This one is genuinely open-ended.
They pointed it at 12 hard construction problems from a known catalog, and on 5 of them the agents produced results new to the mathematical literature. The easiest one to picture: how many identical balls can touch one central ball without overlapping? In 2 dimensions, the answer is 6. You can check it with coins on a table. In 11 dimensions, nobody knows the answer, and the agents push the known floor up to 604 touching balls.
The claim that separates this from a brute force search script is explanation. The authors stress the agents produced not just constructions but theorems and analyses explaining why the patterns work. A search returns an object. A collaborator returns an object plus an argument that the pattern continues, and only the second is something a mathematician can build on.
And you can watch the record climb in public. 600 in June, 604 2 weeks later, each step with a published construction notebook attached.
Purity. My checks though. That catalog is curated for machine searchability, so 5 of 12 is a score on a friendly board, not a claim about mathematics generally. 7 problems yielded nothing new, and on some of them the agents did worse than the published state-of-the-art. And the compute bill, commercial API keys running throughout, is real and unpublished.
But every raw agent dialog, proof, and verification script is released for anyone to audit. Between this and the rank records, that's 2 results today where you don't have to trust anybody. You can just check. For the local model crowd, today was merge day. Support for Qwen's next-generation architecture landed in llama.cpp, the engine most people use to run models on their own machines, and the port is a beast. 65 commits, and the centerpiece is machinery for a 97GB lookup table.
Which deserves a beat of explanation because it's a strange object. This Qwen model stores billions of its parameters not as numbers you multiply but as a giant table you look things up in. Elegant on paper, a nightmare for inference software. Every loader ever written assumes parameters are tensors you push onto a graphics card, and a table that size doesn't fit on any consumer card.
The trick is that it doesn't need to. A lookup only touches the handful of rows relevant to the text in front of you, so the port keeps the table in ordinary system memory and pulls rows on demand.
And the engineering detail that tells you the port is clean. It needed 0 new operations in the underlying math library. Everything new was expressible in what the engine already had. That's the difference between a port that lands and a port that forks the project.
What it means in practice from community reports. A 4-bit build running on a 16GB graphics card at around 20 tokens a second, with roughly 100 GB of system memory holding the rest.
Pity. One claim circulating with the release to throw out, though. Post said this model beats DeepSeek's flagship. Qwen's own model card benchmarks it against the smaller Flash sibling, and no published table shows it beating the big one. Confirmed versus claimed. Keep them separate.
So let's be precise about what this is. Not a small model. A model whose bulkiest component was deliberately made cheap to keep an ordinary RAM, so a modest graphics card does the compute while a big pile of memory does the holding.
It's a bet on abundant, cheap system memory as an architecture decision, placed, as it happens, in the exact quarter that system memory stopped being cheap.
Because here's what happened to memory this year. Contract prices for conventional RAM, the sticks in a desktop, nearly doubled quarter over quarter in early 2026, and the analysts tracking it forecast another jump of more than half again on top of that.
Moves like that do not happen in commodity components. Memory is famous for gentle multi-year gluts punctuated by mild squeezes. A near doubling in one quarter is a different kind of event.
And the mechanism is worth getting right because AI is eating the RAM is only half true. AI accelerators use high bandwidth memory, a specialized stacked product, not desktop sticks, but both come off the same wafers in the same fabs. Every wafer devoted to the high margin product is a wafer not making the cheap one.
The bakery that discovers wedding cakes pay 10 times what bread does. No flour shortage anywhere. The bread shelf still empties.
And the cloud providers have shown they'll accept the higher prices, which teaches every other buyer to pay up or lose their allocation.
Why it belongs in an AI show. System memory has quietly become an AI component. The architecture we just talked about parks 100 gigabytes in system RAM precisely to dodge expensive video memory. That was a clever arbitrage right up until ordinary memory started repricing too.
The graphics card leg of the squeeze is easier to see. NVIDIA's flagship consumer card launched at $2,000. Retail listings checked during this reporting sat well above twice that. The cost of a machine that runs a big model at home has moved a long way in a year.
Counterpoints, briefly. Contract prices are what large buyers negotiate, not what you pay at retail this afternoon, and the two can diverge for months in either direction. And if the AI server build-out slows, capacity swings back to the cheap stuff and this unwinds fast.
Meanwhile, the local community's actual response hasn't been buying more memory. It's been compressing harder. Models where only a fraction of the parameters are active at once, aggressive quantization, careful cache budgets. Running models at home was always a fight against memory. It just got more expensive to lose. Google shipped an update to its video model Gemini Omni 1.1 Flash, and the headline feature sounds small and isn't. When it extends a clip, it now reads up to 10 seconds of what came before. Previous models looked at 1 second.
And the reason that matters. The standard trick for longer video is feeding the last frame back in and generating onward, which works about as well as writing a novel where each chapter begins by reading only the final sentence of the previous one. Characters drift, lighting shifts, the jacket changes color.
10 seconds of context means it's continuing a shot instead of guessing from a still. And you can now pin a first frame and a last frame and have it generate the movement in between, which is how you get a camera move that actually returns home, or a loop that closes cleanly.
The other half is price engineering. There's a cheap low-resolution draft mode at about a third the cost, and the full rate works out to roughly 10 cents per second of finished 720p video. The intended workflow is explicit in the announcement. Draft several cheap variations, vary one thing at a time, pick the keeper, render it at high resolution.
That's a production pipeline, not a demo, and the customer's name back it up. Adobe has it inside Firefly, and Figma's video tool describes the new controls as directing rather than generating.
Limits stated plainly. 40 seconds total, maximum. No downloadable waits, API only. And the sharpest complaint from developers is that it still can't sync generated video to audio you supply. At 10 cents a second with a normal number of takes, a 30-second finished spot is a real bill.
Still, the competitive axis in generative video has moved. Everyone's clips are pretty now. What separates tools is controllability and unit cost, the boring features that let output enter an actual edit timeline. This release is all boring features, and I mean that as a compliment. Australia's chart body, ARIA, just became one of the first in the world to turn the music industry's unease about generative audio into an enforceable rule. From next week's chart, wholly AI-generated tracks are ineligible. AI in a supporting role, pitch correction, generated drum parts, mastering tools, still counts.
That's the only defensible place to draw the line, because a rule against any AI involvement would delete half of contemporary production. The test isn't whether AI touched the record. It asks whether a human substantially made it.
And the enforcement has actual teeth. Retrospective removal from the charts, withdrawn accreditations, and they can revoke a #1 award after the fact. A track can chart, get celebrated, and then be unwound.
The CEO's argument is narrower and stronger than machines bad and worth taking seriously. Her point is that a chart rewarding output from services trained, unlicensed, on artist recordings is measuring a loop, ranking generated tracks above the very catalog they were trained on.
The provenance objection, not the synthesis objection. She's fine with artists using AI tools. She's not fine with the chart laundering the training data.
My skeptical note, there is no detector. Eligibility rests on disclosure plus adjudication, and the hard cases live in the middle of the distribution, a synthetic vocal over human songwriting, a human vocal over a fully generated arrangement. Those records exist in commercial quantity today. The new disputes process is a tacit admission these calls will be fought.
Charts aren't just scoreboards, they're the allocation mechanism for radio play, playlist placement, and touring money. Deciding what counts is deciding where the money goes, and ARIA explicitly called on radio to adopt the same rule. Every other national chart body now has a working template to copy or reject. And the essay everyone in tech was passing around. Calvin French Owen, who co-founded the data company Segment, arguing that cheap fast models have crossed a usefulness threshold. His anchor is one repeatable task, a personalized daily news site he generates for himself, that cost about $1 a run on last year's mid-tier models and now costs about a dime.
Framing is why it traveled. Investors keep asking him why there are so few consumer AI companies, and his answer is unit economics, not vision. At $1 per session, a consumer app charging $30 a month is dead on arrival. At 10 cents, it's a normal business.
The half I found more interesting. He and his old co-founder split work into two buckets. The rare stroke of genius work, and what they call token spewer work. Being ultra-responsive, nudging people, pushing a dozen fronts forward at once. The co-founder, who runs multiple companies, put 95% of his own job in the second bucket.
And the claim is that bucket 2 is exactly what a fast, cheap, good enough model absorbs. Note what he is not claiming, though. He expects demand for frontier models to keep compounding for anything that needs genuine discovery. This is a second market opening, not the first one closing.
The supporting evidence around the essay is stronger than his own anecdotes. There's a 22-gigabyte local coding model matching far bigger systems on a small slice of real bug fixes, and at the absurd end, a model with under 30 million parameters running on a $5 microcontroller.
Which, per its own documentation, can write short stories and cannot answer a question, follow an instruction, or write code. That's the honest boundary of good enough. It's a claim about a task, never about a model. And his cost figures are self-reported, not benchmarked, which the comment threads did not fail to notice.
His own to-do list is the deflating, useful part, better harnesses, prompt injection safety, roles and permissions. The remaining gap is less about model quality than about plumbing, the scaffolding that stops a cheap fast agent from doing something expensive and irreversible. If today has a thread, it's verification. The lab agents that can't tell when they're done, the canary strings that didn't survive a fork, and the mathematicians publishing witness points so nobody has to trust them. A claim without a check is just vibes, and the field is slowly learning it.
With the math leaderboard as the existence proof that checking can actually be done right.
In today's other episode, we go deep on the big one, the lab that runs itself, and the same-day benchmark that says don't trust it yet. That's the deep dive if you want the full mechanics.
And every story from today lives at groundtruth.day, our news site, with links to every primary source, the risk report, the pull request, the leaderboard entries. Groundtruth.day every day.
If the brief was useful, follow the show, and drop a comment naming the one story you want us to take apart properly. The risk report is currently winning that vote in my head.
It would deserve to. See you in the deep dive.